In this video tutorial, we will learn how to run a test with the MagTest system. First of all, as we already explained in the previous episode, we have to set the proper limits. In this case, we will make a test according to this ISO normative. As you can see, for each frequency, there are the requirement for different field strength. In this case, these limits are shown in ampere per meters. We click on OK, and then we can see the curve of our limit in the plot. We can see also the legend for the devices that we are measuring, the shunt, that is the current probe, and the monitoring loop that we will measure through the multimeters. Then we can click on hardware configuration, and we can have a summary of all the configuration that we already implemented in the previous episode. Once all the settings are loaded, we can go to the application bar and simply click on this button that will start a test. In this moment, the function generator will provide a signal to the power amplifier, and the feedback given by the loop and the current probe will work in order to regulate the produced field strength in order to reach the level that is required by the normative. Now we are testing at a low frequency, and the red dot is showing the point in which we are performing the test. Now we are already scanning the second point, which is at higher frequency. The field strength is in adjustment now. And then we are passing through the following data point at 6 kHz, which is now under test. The measuring time at 6 kHz is finished, and now we are at 150 kHz. We can also modify the legend on the vertical axis and the scale. In particular, we can see the limits in the different unit of measure: decibel microampere per meter, decibel picotesla, and ampere per meters. As you can see, we have finished now the measurement, and the result of the measurement are overlapped to the normative curve. The green curve is related to the current probe that is measuring the current that is flowing in the circuit, and the azure curve is related to the measuring loop, which is located into the center of the Helmholtz coil. Now we have zoomed a bit inside the plot, and we can change the hardware configuration in order to make a finer step test. In particular, we can change the step size in order to increase the number of points that we are testing. We can start another test, and we will see now that in this way we can test more frequency point than the previous case. This is useful in the case in which the user has more time to perform the test and wants to have a more finer division in the frequency axis. As you can see now, the frequency test is ongoing at lower frequency, but for a very high limit in the order of 1000 ampere per meter. We can also zoom to learn more about the current situation. And we can follow the test. During this interval of time, the device under test is located inside the Helmholtz coil, and the device under test can also be moved in order to test under different configuration of the geometry. Now we are around 0.05 kilohertz. And since the test will be very long, in this case we can stop it to show other function. We can stop it in any time, and the test is now finished. We can export the result as a text and as an image. These data are saved in the cache of the computer and can be retrieved by other editors. It is also possible to use the other option, for example, removing the current measurement from the plot.